Hello, everyone. My name is Nitin Motgi, and I am the product lead for JCP's data analytics data integration portfolio. Today, I'm here to talk about the importance of discover, move, and trust as the fundamental building blocks for data analytics and how GCP has been innovating around these three areas to help customers with digital transformation and insights. So let's get into it. In the era of cloud, enterprises are putting a high value on data integration, particularly to support corporate-wide business analytics and the BI efforts. Data integration is essential to the ongoing operations to more than 80% of the business. Hence, they are always on the lookout for technology that will assist them in answering some of the most difficult, fundamental, but yet difficult and complex questions. Questions like, how can I catalog and make it simpler to discover all the data that is now dispersed into in not just in within the corporate systems, but also across clouds. As you can see, 51% struggle in finding the content that they need in order to do the analysis. The harder it gets to, discover the content, it's more likely that the business initiatives might fail. The second thing that is important once you discover the data is in some cases, you would have to move the data. You would have to deliver the data to the right systems. So there are many different systems that you interact with, and data delivery methods need to be different depending on the use cases. And as you can see, 80% of the organizations actually use a variety of data delivery methods to leverage data. 80% of the organizations leverage different data delivery methods to land the data into various different systems. And last but not the least, whether you're searching for a data to comprehend it, or you're making sure or ensuring that the data has been transferred reliably or effectively, you have to look at metrics that allow you to trust the data or the process that actually moved the data. As you can see here, large amount of money is lost on a monthly or a daily basis. 15 million on an average is lost because the organizations cannot trust the data actually that they're using to build models or reports. So now, how is Google helping this? And how is this critical for digital transformation? Let's look into that. As you guys all know, digital disruption is the stark reality for virtually every organization, and it has increased so as a result of worldwide epidemic. GCP has been a close partner for numerous organizations across the globe, helping with digital transformation. At GCP, we are doing more to assist our customers as they transition from infrastructure transformation to the next phase of digital transformation by providing highly differentiated platform that provides a holistic solution on simplifying three critical components of the data supply chain: discover, move, and trust. We would like our customers to be able to easily find the content they are looking for across enterprise landscape on GCP and beyond. That said, we not only want to help find that information, but also enable business users to augment their technical metadata with business metadata, overlaying the business context on top of it so that it can interpret that data very easily. Now, the question is all about, once you have identified the content that you want to work with, you might have the need to move it to the required target storage or to do further analysis. This area is far more complex and it's very time consuming, and it involves different variety of systems that are required in order to make this much more reliable. And also it needs to support different level of expertise, technical expertise, and skills are required to move this data. And this is where the data movement becomes a critical component to it. Now, whether you're looking to build a model or a business report that is critical, you always have, or you have recently moved the data, you always need to be able to trust the data as well as the process that actually moved the data from one system to other. Example, if you're moving data from SAP systems into BigQuery, you need to be able to trust the process that actually is moving the data. You need to be able to be confident about the data and the process in order to reliably use them to make business decisions. Hence, GCP's data integration portfolio of products are focused on simplifying and bringing together these three different capabilities: discover, movement, and trust together. Discover is primarily focused on improving the productivity and improving and accelerating analysis by enabling users to find data more quickly. Movement is focused on providing different data delivery mechanisms to reliably deliver the data to the target systems with a lower skills barrier. And also, the trust is primarily focused on providing the confidence in the data and the process that can be leveraged to make business critical decisions. Now, before we jump into the details of each one of this, let's primarily look at the use cases that are powering. Let's start by looking at the critical use cases that are powered by Discover, Move, and Trust. Let's begin with data migrations. Data migration is primarily focused on ingesting a large variety of data sources, mainly operated by administrators, it requires very simple no-code to low-code interfaces because there's massive amounts of data. There's a lot of complexity involved in it. The simplicity of being able to move that data reliably and at scale is critically important. So this is one of the primary use cases for data integration. The next use case is in building data warehouses or accelerating data marts and data lakes. The creation of data lakes. These are mainly driven by ETL developers and data engineers, and they are looking for ways to improve the business IT collaboration and lower their TCO costs in general. Now, this use case is the most primary one from a GCP perspective, as many customers are looking for building their data warehouses on BigQuery. Now, when you think about it, this is not only the technologies that are used for building data warehouses can also be leveraged for building data lakes and data marts. As more businesses start to move their data move their data in real time in a streaming fashion, building streaming data lakes has become extremely important, or event-based real-time insights has become important. The solutions are primarily, again, developed by data engineers, but while they prefer to have a finer optimization controls, they would also prefer ability to ingest this data in real time so that they can focus on the core business logic rather than focusing on just moving the data from point A to point B. So that's essentially the component for streaming analytics, and that's a very important use case in this era. The next one is all about operational reporting. The change streaming from operational systems, stores, or into warehouse is vital in enabling organizations to get more insights in real time and quickly from their applications. The data being streamed into warehouse allows them to have much robust real-time reporting of the data that allows them to make critical business decisions quickly. So this is one of the primary use cases also being evolved into a critical use case for from a data integration point of view. Now, in a complex enterprise landscape, there are multifaceted data movement capabilities required, and all lead to complex processes that need to be stitched together with a robust orchestration capability. So a data integration use case should also encompasses a capability for orchestrating all of these complex movements of data through a well-formed orchestration tool. So which is primarily used by DevOps or used for data operations. And last but not the least, to top it all, having a shared catalog, the users can share across the organization to discover content is critically important. So now, when you bring all these things together, right, in order to serve the customers of data, the needs of the customers that require data integration, we have to bring the three areas: discover, move, and trust closer together. While they are all interrelated capabilities that we offer, like GCP offers in each area today, it is important to understand how each one of these can be fit together with the capabilities that we have today in the GCP portfolio. So let's start with the core. At the core, aggregating metadata and making it easier to discover across all of the GCP data and beyond in future helps drive an overall better data integration process for across the organization. Leveraging extended metadata to provide better understanding of flow of data with lineage enables governance. Once you know how the data is flowing, it gives you more insights and more capabilities in terms of understanding not just the flow, but also what processes are involved in in basically generating the data, and how all of these data elements are connected together. Then you would have to have the ability to combine this with additional business metadata that will enable business users to make more sense of the technical metadata that is automatically aggregated, right? A combination of data catalog, a GCP service, that is a GA GCP service, and partner tools like Colibra and Alation enable these capabilities within GCP. Now, on top of that, leveraging metadata for better making integrations better, right, is extremely important. Moving data from source system to target requires support for different data delivery paradigms, right? Different data delivery patterns. And we have talked about it briefly earlier. That ranges from batch bulk to real time, and from simple ingestion to chain stream to performing ELT on the data. While moving data is simple in most cases, there is a need for supporting complex transformations like simple mappings to business rules and to business rules while the data is being moved. Like DTS, data streams, data flow, and data fusion are primarily are used for supporting these type of different data delivery mechanisms combined together. Of course, partners like Fivetran and Informatica all provide capabilities ranging from simple ingestion to complex ETL to ELT processes for defining the movement of the data from point A to point B. So that forms the middle layer, which is extremely critical, that is generally powered by the metadata layer, enabling much broader and deeper integrations with varied systems. Now, the movement of data can be complex. It involves multiple steps in the process with multiple data delivery patterns to be included together to achieve the final goal. So that needs a versatile orchestration capability that stitches together complex workflows in the form of that and track the progress and provide an advanced capabilities for scheduling, triggering, and backfilling in cases when there are problems. So these all three layers combined together form the basic building blocks of data integration within GCP. They are core and they enable you to have a much more end-to-end user experience for building a full-fledged data integration solution for data warehouses, data marts, and data lakes on GCP. Now, let's look into what are some of the value propositions of each of the products in each of these areas and how they relate to the capabilities that we have today. So let's begin with data catalog. So data catalog provides, as of today, has a data discovery capability, which allows you to, where data catalog automatically indexes a lot of metadata, and it provides a simple and scalable keyword search capabilities for business as well as technical users. Now, the auto ingestion is a very important part of the catalog because when the systems within GCP are integrated, the metadata from all of those assets that are being created, whether you're creating a table in BigQuery or you would be creating a table in other systems, those will automatically be integrated into data catalog. So another system that it is integrated deeply with is Dataplex. So any assets that are created within the lake and zones are automatically made available within data catalog. Auto tagging. Auto tagging is an important feature which is when integrated with data catalog for identifying sensitive data, whether the data is in BigQuery or soon to be in Dataplex. You will have the ability to combine and identify critical data that you can use for reporting to ensure that there are no data leaks or there are sensitive data have been applied right set of policies. And the technology that is used underneath for this is DLP. This is the data loss prevention protection service that is integrated into the catalog to enable this. Business tags. So real business tags. So real pre-built tag templates. So the business tags can be currently developed using the tag templates. And it's a great way for associating additional information to the technical metadata that is being provided, right? So those are some of the areas that are critical from a catalog perspective. Now, there are two other areas that are important, one from a governance perspective and another from being open about it. So access control. Access control, having a unified and integrated security with IAM is critically important. So you have the ability to provide granular access control of metadata accesses, so you can control who has access to what metadata, right? In cases you don't want certain metadata to be available to a certain parts of the organization, you will be able to control it. And last but not least, you have the ability to expose all of the data that's within data catalog through APIs. So data catalog provides open APIs that allows you to read, write, or search metadata. It's also available in various different programming languages like Python, Java, Go, Ruby, etc. Right? So these are all the different capabilities that catalog provides, and that forms the base layer of discover, move, and trust stack that I just talked about. So now let's look at some of the data movement capabilities that we have within GCP, right? So when you look at the movement capabilities, like I talked about briefly, there are different data delivery patterns that have to be supported as part of data integration. One is simple ingestion. You want to be able to take the data from a source system and be able to easily make that available in the target system. Now, how can you do that, right? And you want to be able to do that both in batch and streaming. So today we have DTS that allows you to bring data from SaaS sources with few clicks into BigQuery. It's easy to configure and it's simple to use, and it works reliably. And it's always available. It's completely serviceless. We can talk about it a little more in upcoming slides. The second use case, that data delivery pattern that's important, is replication or change stream handling. So this is one of the patterns that is used for building operational analytics. So you want the data to be made available in real time as the changes are happening on the operational systems, or they might be on applications. You want to be able to take the changes and replicate that into BigQuery, as for example, and then be able to run analytics on that. So for that, we have a service named Data Streams. Now while simple ingestion is true, you want to have more. In many cases, you want to have the ability to simply ingest the data without doing any transformations. There are also cases where transformation is required, whether you are trying to blend, map, combine, aggregate data in various forms. You need to have some kind of an ETL capability. And that's where Data Fusion comes into play. And Data Fusion provides the ability to run transformations in flight as the data is moving from source to the target. And now Data Fusion currently supports running it on Dataproc and Spark engines. And there's now the ability to push down, certain joins into BigQuery directly without having to, extract the data out, join them, and put that back in together. It's only specifically available for joins. So joins are being pushed down into BigQuery. That allows it to use the scale of BigQuery to handle massive skewed joins. And they are efficient in certain use cases, but not in all, right? So you have to use that very selectively. The last but not the least is post-storage transformation, which is ELT. As warehouses have gotten more powerful with the scalable compute and separation of storage and compute, now you have the ability to not only transform the data. You don't need to transform the data outside of the warehouse. You now have the ability to transform the data after you put the data into warehouse. So because of the scalable compute, you can do more complex operations, and you can deliver that with BigQuery SQL even today, right? So a lot of organizations use this type of mechanism to deliver and generate the target data set with all of the transformation being applied after the data has been ingested. So customers find a combination of simple ingestion and post-storage transformations with ELT as one of the choices that they use in terms of delivering the data to their businesses. And last but not the least is, while orchestration is important, where Composer is being used, it allows you to not only stitch the data, but it also allows you to have custom code that brings the data from various different source systems. It could be a data flow job. It could be a Spark job. You can stitch together those into a DAG that allows you to execute them end to end. So that's all about different data delivery patterns. We can briefly get into each one of this and talk about what value propositions do they bring. So as I talked about data fusion, which allows you to do ETL, it enables various integration patterns within it, right? So you have transformations, you can do wrangling, you can map stuff, apply simple rules and transformation rules that are being applied. It supports both streaming and as part of the integration with data stream, it also supports replication. So you can use this visual tool to build pipelines and experience that allow you to bring data from point A to point B in a much more unified platform. It has an execution engine that runs on different engines that we talked about, which is Dataproc or BigQuery. Now, the most important thing is it also integrates with a lot of different Google ecosystem services. So, it's integrated with AI, it's integrated with data loss prevention, and, it also is integrated with like DLP, for example, right? Data loss prevention is DLP. So all these are have been integrated into a unified platform with a visual tool that allows you to build the DAGs end to end, right? And that is the core value proposition of data fusion. Looking at data streams, right? Data streams value proposition is having the ability to synchronize data in real time with minimum latency across heterogeneous databases, storage systems, and applications, right? So having that ability is critically important. And when you look at it, the data streams currently delivers change streams from Oracle and MySQL, and it delivers that into other Google services, like for example, BigQuery or Cloud SQL or Postgres, Cloud SQL for Postgres, or GCS and Spanner directly, right? So it makes it extremely easy when you have to bring the data from in real time from source systems directly into the target. And it's a very simple interface to use. Once it's set up correctly, all of the data is continually available. So you can do really fast analytics on top of the data. So DDS is a managed service within BigQuery. DDS is completely serverless. It's always available. There is literally no code for you to move the data. You just have to configure, provide the configuration for the source system, and it directly lands the data into BigQuery. And of course, you can transform it using BigQuery SQL after that. It's completely serverless, and important of all, it's free. So all of the connectors that are available there allows you to connect to various different SaaS sources and some of the cloud sources to bring that data into BigQuery at an extremely fast rate and being extremely simple to configure. So these are some of the the data delivery patterns that we talked about. So when you think about what is the value proposition from a composer perspective, like I said, it's the data ops tool that allows you to measure, construct the DAG, orchestrate complex workflows, whether you're orchestrating a bunch of BigQuery jobs, Dataproc jobs, Dataflow jobs, or other Google products combined together, right? So it stitches all of those tasks together in a much more cohesive way and provides you an end-to-end view of it. It also provides data operations capability where you can monitor the progression of a job through the entire DAG. It provides a very simple deployment, and it is it provides auto scaling capabilities, which is completely managed. With the composer, what it allows you to do is it allows you to focus on business goals rather than you trying to figure out what are the right scaling properties for this kind of job. It automatically gets handled completely. Composer is based on Airflow, and it's open source Apache project. And there is portability between Airflow and Composer. So you don't have to worry about if you build in one, you cannot migrate it over. It's 100%, it's totally compatible, and you can move a job from Airflow to Composer seamlessly, or the other way around also holds true. So these are different capabilities that GCP currently provides in terms of the stack which we talked about for move, for discovery, move, and trust. So not only that we provide this capability, partners are also very vital to the success of our customers to better support the needs of various customers we have partnered with, industry leaders in this data integration space. And we work with all of these partners very closely, supporting digital transformation for our customers. And with that, we come to the end of this presentation. Please try out the products to see if they meet your needs. And if there are gaps and you would like to talk to us, please don't hesitate. We love collaborating with you. Cheers, and thank you for listening.